Hello everyone. In this video, we will cover varying continuous insurances. And in this video, we only cover the insurance policies whose death benefit follows a linear pattern. The first type of varying continuous insurance we cover is the annually increasing or annually decreasing insurance. Let's consider first an annually increasing whole life insurance issued on an individual at age X. The death benefit pattern, BT, equals to the floor of T plus 1, payable at the moment of death if death occurs at time T. That is, if the individual dies within the first year, the death benefit is 1. If the individual dies in the second year, the death benefit is 2. And the pattern continues. The actuarial notation corresponds to the expected value of this type of insurance is IA bar X, which equals to the integral from T equals 0 to T equals infinity. If there's an limiting age, the upper limit is replaced with the expression omega minus X. And then the integrand is the death benefit amount times the present value factor times the PDF of Tx and then dt. An annually increasing n-year term insurance, we have this actuarial notation. Suppose n equals 4. If the individual dies within the first year, the death benefit is 1. Until the last year, if the individual dies in the last year, the fourth year, the death benefit is 4, and then 0 afterwards. The expected value is given by this expression. And then for an annually decreasing n-year term insurance, the death benefit BT is n minus the floor of T, payable at the moment of death if death occurs at time T within the n-year period. That is, if the individual dies in the first year, the death benefit is n. In the second year, the death benefit is n minus 1. Until the final year, the nth year, the death benefit is 1, and then 0 afterwards. The actuarial notation for the expected value of this insurance is DA bar, and then the remaining notation corresponds to an n-year term insurance. And the expression for that, T from 0 to n, the death benefit amount, the present value factor, and then the PDF of Tx dt. An illustration with n equals 4. We have this death benefit pattern, start with death benefit of 4, and then reaching a death benefit of 1 in the final year. And this is the expression for the expected value. The relationship between the annually increasing and annually decreasing term insurance. For IA bar, we have this expression. And then for DA bar, we have this expression. Add this up. If we add up the floor of T plus 1 and 4 minus the floor of T, we get 5. Factor out this 5, and then we get the integral. The integrand is e to the power minus delta t ftx dt, and this corresponds to a 4-year term insurance. So we have IA bar with n equals 4, together with DA bar with n equals 4. We add this up, we get a 4-year term insurance with level benefit. The level benefit amount is 5. generalize it with the N-year term insurance, we get this relationship. Next, we move on to the second type of varying continuous insurances. This is a continuously increasing whole life insurance. The death benefit pattern is BT equals T. If death occurs at time T, the death benefit is payable at the moment of death. Therefore, BT is a continuous function. The corresponding actuarial notation for the expected value is I bar A bar X with an additional bar above the I for continuously increasing insurance. The expected value is given by this expression. The same formation for the integrand, the death benefit amount, the present value factor, and the PDF of Tx, and then dt. For the continuously increasing N-year term insurance, as you can expect, the death benefit stops beyond hx plus n, beyond the N-year period. And then we have the actuarial notation together with the corresponding expression for the expected value. For the continuously decreasing N-year term insurance, the death benefit pattern is BT equals N minus T if death occurs at time T. Here we have the diagram for the death benefit pattern. If the individual dies time T, that is at hx plus T, where T is between 0 and N, the death benefit is N minus T payable at the moment of death. The actuarial notation is D bar A bar. And this is the expression for getting the expected value for this policy. All right, the relationship. If we add up the expressions for I bar A bar and D bar A bar, we get the integral with a constant n and then times the remaining expression here. And the integrand here, integrals, is the N-year term insurance. So we have the relationship. The sum of I bar A bar and D bar A bar, we get a level death benefit of N payable at the moment of death. And this is a N-year term insurance with level benefit. All right, let's take a look at an example. Given that the force of mortality, mu 50 plus t, is a constant 0.02, and the force of interest, delta, equals 0.06. Calculate IA bar and DA bar for a 3-year term insurance. All right, for the annually increasing insurance, we have this expression. The death benefit amount, the present value factor with delta equals 0.06, and then the PDF of Tx, TP50, mu 50 plus T. And the PDF is given by this. All right, IA bar. If the individual dies in the first year, that is from T equals 0 to T equals 1, the death benefit is 1. And in the second year, corresponds to t equals 1 to t equals 2. The death benefit is 2 until t equals 3. And then perform the integrations, and then we get IA bar. This is 0.1038. The second part, the corresponding DA bar, we have the expression. The first term corresponds to the first year, t equals 0 to t equals 1. The death benefit is 3. Start from the value of n, and here n equals 3. And then in the second year, the death benefit is 3 minus 1, which is 2, corresponds to the time point t equals 1 to t equals 2. And then the final year, the third year, the death benefit is what? Upon calculation, we get DA bar equals 0.1095. We can further verify the relationship. All right, we have IA bar plus DA bar. These two numbers add up together, we get 0.213372. And then the expression on the right-hand side, we need to get a 3-year term insurance at age 50. Doing the calculation, we get 0.0533 with n equals 3. We get the same numerical value. All right, another example. A continuously increasing whole life insurance on an individual at age 25. The death benefit is T, payable at the moment of death if death occurs at time T. Mortality loss follows the function Lx equals 110 minus x, where x is between 0 and 110. Force of interest delta is 0.04. Calculate the expected present value for this insurance. All right, we have a continuously increasing insurance. So we have I bar, A bar. This is a whole life insurance. We have X here. There's a limiting age. So the upper limit of the integral is omega minus X. Here, omega is 110 and X is 25. We need to get TPX and mu X plus T. The mortality follows this expression. So TPX equals Lx plus T over Lx. And then the force of mortality, we can use this expression. And we get 1 over 110 minus X minus T. And therefore we get TPX times mu, which is 1 over 110 minus X. Doing the substitution, we get I bar, A bar, 25. Omega minus X, 110 minus 25, we get 85. Delta, 0.04. And then 110 minus X, we get 85. So we get 1 over 85 here. Upon calculation, we get the expected present value, 6.2732. All right, that's it for today's video. Thank you for watching. and see you in the next video.